working with a custom contract. I don't know, I found some issues that like it was like really good with rates case, but I think like for test accounts,
some stuff.
I've seen your face before, like I don't know a couple of things going on.
Oh, cool.
It goes around. Are you still learning a lot? So, but you guys work on what exactly
Yeah.
You are unmuted.
All right, everybody. Thank you so much for coming. Appreciate you guys. Thank you again. I hope you guys are enjoying some croissants and some coffee. Thank you so much for being here. My name is Kevin Jones. So I work as a DevRel engineer working on the graph protocol. So I support building subgraphs, yeah, along with Marcus. And I also am a core member of the Build Guild. I support Scaffold ETH. So we have, basically today we have 2 workshops, so actually 3 workshops lined up for you. First one's going to be focused on like building a dApp, how you kind of can use Scaffold ETH to get started quickly. And then we're going to do another workshop that gets more into like subgraph development, how to write a subgraph, how to deploy a subgraph, query a subgraph. And then I think we're going to have someone talk about substreams possibly, and which is a new kind of way of doing data streaming with the graph. And then we're going to have a Phoenix as well, do a little quick introduction about what Phoenix is towards the end. So thank you so much for being here. Let's just get started. So I guess show of hands here. Who's hacking? Oh, woo! Awesome. Wow, that's amazing. Cool. Okay, that's great. No, that's fine. You can hack even if you're not like doing the hackathon. You know, you can do it today. So that's good because Scaffold ETH is like definitely something you should be using if you're new. Who here has participated at Hackathon before? Who's their first time? First time. Okay. So Scaffold ETH is going to be a huge bonus for you if you're a first time hacker, and even if you're a veteran hacker. It's got kind of everything you need to get started quickly. It's basically what we call a starter kit or a mono repo that contains a bunch of packages and a bunch of pre-written code for you. It comes with Next.js, which is basically React with Next.js on top. It also comes with Rainbow Kit, it comes with WagMe, and it's all TypeScript. So it's very easy to interact with the packages. And it also supports Hardhat or Foundry, so you can pick which chain you want to use. Some people prefer Foundry because you can do Solidity smart contract tests, and it might be a little bit more performant in some cases for testing. But there's 2 ways to get set up with Scaffold ETH. You can either clone down the repository, and feel free to follow along if you want. I might move kind of fast, but the good thing is we are streaming this on our Twitter account, so you guys can always go back and watch it again if you fall behind. And there's lots of other videos about this online. So you can clone the repository, or you can use npx to install the packages. I recommend using the npx command. It says here that it's beta, but it's really not. It's really works really well. We don't have any issues with it. And then you can access the docs for the GitHub. So if you just go to scaffoldeth.io, that will take you here. The docs are really great. We're going to dive into them a little bit and learn a little bit about the components and the hooks that we have, which are all here on the left. And if you want to look at the source code, obviously it's all on GitHub. You can see kind of the commits and everything going on there. There's a lot of different packages of scaffolding. More importantly, there's a really cool one that's called the subgraph package, which is right here. It's a build a scaffold ETH that comes with the subgraph already in it. So we're actually going to use that. The cool thing is it's an extension. So there's also a section here that talks about extensions. But extensions are ways that you can take scaffold ETH and extend it with some added functionality. So the core functionality for scaffold ETH is React with Next.js and Hardhat Foundry. But you might prefer to use some other kind of extension. You can come and see or look and see what's available. The very first extension ever published was a subgraph extension. And there's also Ponder, Unchained Kit, ERC20, and EIP712. So really there's a lot of options. And there's also third-party ones as well. So you can just create your own. And there's a guide to that as well, which is really cool architecture where you can kind of extend scaffolding to do whatever you want. But let's use the subgraph extension for what we're going to do. So we're going to use this npx command right here. And we're just going to get started right away. We're not going to do any slides, nothing like that. So we're going to do npx create ETH at latest, but we're going to add -e and subgraph. So what that's going to do is just going to bootstrap our application. It's going to ask you to install the newest version of create ETH, which I've already done, and then it asks you what you want to name your project. By the way, can you guys see that okay in the back? Is it big enough? So we are going to name ours How3. Sure. So this is where it's going to give you this kind of like choose your own adventure, choose Hardhat Foundry. I personally like Hardhat. It's been around a little longer. It's just, I know it a little more. You might want to use Foundry if you want to write your tests in Solidity. That feature is actually coming to Hardhat. If it's not already there, I think it's coming soon, but I use Hardhat. So this is going to like scaffold out the environment for you. It's going to basically create a directory. It's going to install the 3 packages you need in this case. So it's React and Next.js, Hardhat Foundry, in our case Hardhat, and then the subgraph folder as well. So it's 3 packages. It's going to format all the files using Prettier, and it's going to initialize an empty Git repository for us. Okay, so that should just take a second. With scaffold ETH, you always need to have like a few windows open to kind of orchestrate your environment. So you can either just do this in like separate terminal windows, or you can use a tool that I use called Tmux. It allows you to do like some commands to like split your screen up. So you can do like this, split the screen, split it into the screen so we can kind of see what's going on. We can see we're still installing all of our dependencies up there, so we'll get to a second. Oh, there it goes, it's done. So let's go into this directory on all these terminals. Oh. So Tmux is really cool because you can see everything going on at once. Now, if we go back to this very first window, we can see what we need to do. We need to go into CD How3, and then we need to, it tells us, well, how do you start the chain? Yarn chain. How do you deploy your contract? Yarn deploy. How do you do a front end? Yarn start. So it gives you everything you need to do. So we do a yarn chain first, which spins up, in our case, Hardhat. And that's going to, oh, I'm going to have Hardhat running, so I need to close out the other one. Let's see. Sorry, I forgot that okay, so do it again. Yarn starts. Yarn chain first. And then in this next directory, we're gonna, so now we have the chain running. So like, depending on what chain you're running, you get these kind of like play accounts that have some ETH in there for you to like test around locally. So that's what you see out there is the console saying that those are your private keys. Those are shared private keys. We'll get to that in a second, but you shouldn't be using those on a public testnet. Then over here, we're gonna start up our front end. So first window is our chain. Second window is our front end, right? So we're gonna run yarn start. So now that's it, React's up. And then this third window, we're gonna do our deploy. So yarn deploy. Now, when you do a deploy, like scaffolding basically comes with a smart contract, okay? And it's just a very basic contract. So you get this kind of like console output from console log that says, okay, it was successful. This is the contract address. This is how much gas that it costs, right? Whenever you deploy a contract, you have to pay gas. That's how the Ethereum blockchain works. And we get this output that says, oh, we have a new greeting called Building Unstoppable Apps. And this is the most important line, is we updated all the TypeScript contract definition files. So the beauty of TypeScript is it's basically a extension of JavaScript that creates static types for all of your interactions with whatever you're working with. So in this case, we have a smart contract, and we want to be able to interact with that on our front end. And there's a script that runs that generates all those types for us. We'll see why that's important right now, but we know that the contract was deployed. Let's take a look at scaffolding. So scaffolding runs on port 3000. The first time it runs, it's got to compile like the root page. Give it 1 sec. Okay, cool. All right, so this is scaffolding. So you get this kind of like hello world page that says, hey, welcome, you've got a connected address, which I'll get to in a sec. And it kind of tells you how to debug your contracts and how to look at the block explorer. And we'll see that there's this subgraph tab. I'm not going to quite get there. We're going to save that for the last. But this debug contracts is where I want to focus on right now. So what's cool is because we have those types, scaffolding reads in all those types, and it builds a UI for us right away. So we don't need to like fiddle around with creating front-end code. We immediately can start changing our smart contract and then deploy the changes and then see how they're working. So we know that these are all the variables available in our contract. We have a read function, we have a write function, we can withdraw, we have this kind of like basic contract, we have the address, how much ETH is in there, what network we're on. So if we want to change our smart contract, let's go ahead and bring it up. So I'm going to use VS Code just to take a look at the project. Okay, here's the project. So again, I mentioned it's a monorepo, so it's got these 3 folders, right? So it's got hardhat, Next.js, and the subgraph. So hardhat is where all the chain's going to be, and there's a contracts folder right here, which says your contract. So if we click that, we get the contract that comes to scaffolding. It's called we call it the greeting contract. It's like just a hello world kind of thing where it's like, okay, well here's the greeting. It's currently called Building Unstoppable Apps. We can change it to Building Awesome Apps or something like that. Save it, and then redeploy our changes. And if you want to force a redeploy too, you can also do yarn deploy -- reset, and that will always give you a new copy of the contract, which is kind of nice. And now if we go back to scaffolding, we'll see that that updated and we got a new contract address. Right? If I come over here and do another deploy and reset, this will update again and we'll get a new contract. There it goes. So it's really good for like fast iteration. You can start making changes to your contract and kind of go from there. So we could do like something very basic. I'm trying to think what we could do here. I don't want to go too crazy into Solidity because this is not a Solidity talk, but maybe we could just kind of make some kind of very basic change. Let's see here. What's over here? One thing about this smart contract, I'll kind of walk you through it a little bit, is it has its own kind of owner pattern that we set. So in the constructor, we set an owner. All right, we set this thing called an address. We have an address called _owner, and we set that at the time that the deploy happens. And then we use that variable to like do access control, basically. We require that anyone that has this modifier as owner has to make changes or is like restricted to, has to be the owner. And so we use that actually in the withdraw function down below right here, which says like we can withdraw funds from the contract. You don't really need to know what this code is, but basically this is like dumping all of the balance from the contract into this address, whoever calls it. And so we have this kind of built-in access control. We might actually kind of gut that out, right? So we might want to take it out. So we can grab that out. We can pull out the owner from the constructor. Basically, the constructor is only initialized at the time that the contract is deployed, right? So essentially, you can put anything in there, and then when the contract's first deployed, those variables or functions get called, right? So we want to take that out. We can rip it out. Let's do that. Let's also get rid of the owner variable here. And I'm just kind of showing you how we can make some changes and then do some stuff. We're going to get rid of that owner there and then try to redeploy. So then we kind of see, oh, maybe this is going to give me an error here. Let's actually just get rid of this entire, let's use message.sender instead, which is the global variable. Just gonna call, save it, and now let's try to redeploy it. That works. It's going to give us an error. And that's because we had this constructor that we were setting, right? So the next thing you'll need to understand about scaffold E is there's a deploy script. So in this case, depending on if you're using Hard Hat or Foundry, this is in a different place. For Hard Hat, it's in this deploy folder, and the name of the deployment is here. So it's 00, which is the very first contract. It says deploy your contracts, and this is where we actually deploy the contract. So there's a lot of like comments in here. Let's just get rid of it so you can kind of see what's going on. But basically what we do is we use TypeScript to deploy the contract. And you can see right here, we can pass arguments. So these are what get passed to the constructor. So at the time of the deployment, we say, well, let's set the owner to the deployer. And since we're not needing those constructors anymore, that's why we're getting the error here. So we need to take that out. So we can just kind of get rid of that and then redeploy again. And it should be successful now. There it goes. So it's successful. So you kind of just need to know, like, kind of, this is where you go to like make changes to your deployment. This is where you can like call the contract. So here we actually deploy the contract, and then here we get an instance of the contract so that we can interact with it. And then here we can do something like a console log and call that contract. So we can do a contract call and greeting. So this is a really good place to like test your contract if you want to do some tests. But there's also a test folder. So if we go to your contract .ts, there's a TypeScript test as well. So if I do yarn test, this will test my smart contract to make sure that it's going to pass. There's a good chance that probably, oh, this is really hard to read. So it's actually failing because it's expecting probably some kind of like ownership or something, and I ripped that out. We can actually look at it and see. But, oh yeah, see, it's requiring the owner. So it would be, there's no owner, basically. We're trying to like get who the owner is, but that owner does not exist. But anyway, you get the idea. There's a test here. You probably need to modify it if you want to do tests. Nobody writes tests for Hackathon, so don't do that. But if you somehow are really into tests, then test-driven development is the way to go. You can do it. Okay, so I'm going kind of fast here, but I don't want to get too into the weeds with scaffold beats, like solidity stuff. I want to kind of explore the other areas. So we've kind of made this basic change. We can actually do one more change. Let's import ownable. So another thing is like there's a bunch of Open Zeppelin contracts that already exist. And you should use those because you don't want to have to build functionality that is automatically available from Open Zeppelin from scratch. And so if you're building a token, you want to use Open Zeppelin ERC20. If you're building an NFT, you probably want to use ERC721 or ERC1155. So find out what the Open Zeppelin ones are and use those. And the ownable one is specifically for access control. So it allows you to like require access control to call something. So if you remember correctly, we had this hard-coded right at the beginning. So what we can do is actually use ownable instead. Now watch how easy it is. We can just say, your contract is ownable, save that, and then not test, sorry. Do a deploy. And that should, okay. This is a new function. Let's see. Maybe we need to pass that back in. Let's see. Oh, that's interesting. Okay. Like that's a new change to ownable or something like that. Should work. Okay. Well, let's not do that right now. Let's just keep going so you guys can see more of what scaffold is. So, okay. Well, that's fine. All right. So we'll do a yarn deploy reset just to make sure everything's working. Okay. Cool. So let's say that now you've probably built an application. We're not going to write any Solidity code, but let's assume you guys did. You wrote something cool, right? Now you probably want to build out a UI for it. Okay. So you probably should do that here in this home directory. Like this is cool, but this is not very functional for having someone come and set a greeting, right? If we want to come in here and say, well, what is the greeting, like hello world, like this, and try to change this greeting, so there's a function that allows us to do that. We'll notice here we get this burner wallet. So this is a cool feature of Scaffold ETH where you don't have to connect to MetaMask. There's a wallet built in here, and you can see here that you don't have any funds right away. So we could grab some funds from the faucet like this, and then we can update the greeting. And you'll see here that the greeting changes, right, to hello world. So this UI. You probably want to have some more nicer UI. This is good for testing because you get the transaction receipt. You can paste in the value of what you want the transaction to basically pay into the transaction because it's a payable one. So you would think you could just do like 1 ETH here and send, but this is actually one way. So you actually need to click this little button. So one of the things you learn when you start writing smart contracts is that you need to transact in what's called way, which is a lower denominated value. And in order to really do that, you need to multiply the way in the ether by converting it by basically multiplying it by 10 to the 18th power. So this button will tell you exactly how much way that you need to transact in. So if you have some kind of, if you're doing some testing, it's just kind of a nice little neat developer tool. So now if I do that, I'll hit send. It's going to tell me I don't have enough gas or enough value, I guess I should say, to send that. So I can come back up here, get some more funds, and then hit send. So now you'll notice that the contract has 1 ETH in it right here. And then we also have this withdraw function, which is open right now, so I should be able to withdraw it. There it goes. So I'm able to kind of just test what the contract's doing, but that's the whole purpose of this debug contracts tab. We probably want to start building our app inside here in this home folder. So if we go to the next folder, which is Next.js, there's an app folder. Okay, and then inside here, there's a couple places that you need to know. The first one is the main page, and that's what we're going to edit. So this one, you can see it has all of the stuff that is inside here, which is like the connected address. So what I like to do is I just kind of like rip all these bits out like that, and then I get rid of whatever is not highlighted because we don't need that stuff anymore, and save that. And so now if we come back, we kind of get this like very clean slate to start building with. If we go back and reference scaffold E, and we go to the docs, there's a couple things that you want to know about. The one is these are all the components. So if you notice here, we use WAGMI to get the connected address. So we could display that here if we wanted to. Connected address, save it, and we can see what that would look like. Very ugly. It's just this kind of like string of like long address that no one wants to memorize. If we wanted to make that a little prettier, well, we could go to the scaffold docs and we could say, okay, well, let's take a look at the address component. Now, this is a cool little address component. It has ENS resolution, and it also has like this little copy button. And you can do that by importing the necessary things. So if you look right here, it's a component, right, from scaffold E. So we can grab that and import that. And then we can wrap this in that address component instead. So we can say like address, and then it's address equal connected address. We don't need to have this stuff. Get rid of this. So now we have this component, and we can save that, and then look at it again. Page refreshes, and we'll get this kind of like nice little, copyable, like shorter. It's got also this little like blocky emoji. It's kind of hard to see right now. I'm not the best friend developer, but that leads to my next thing. So we use Daisy UI. So if you go to Daisy UI, you can come up here and you can go to components, and you can grab whatever component you want. So let's say we want to grab a card. I always like to grab the card. We have these like very beautiful cards. And we can say, all right, what's the JSX for this card? Let's grab it, put it in here, paste it in, save it. And now if we go back to scaffold D, we have this card. Well, let's kind of fix it. So let's get rid of this paragraph. Let's say welcome. Let's get rid of the button. Well, no, maybe we'll keep the button. Let's grab this. Let's put it inside. Let's do it here. And let's get rid of the picture. We don't need a Nike thing there. Cool. So now we have this little card. And then we might want to like move it around, right? So we might say like padding 5 or something like that. We might say flex auto, something like that. I can't remember how we did it in the center. That's not the one I want. That's okay.
I want to do it on the outer div, because this is the card one.
Oh, you're saying up here? This is the outside one now.
So that's the card wrapper. So that's the card itself. But then outside you have the fragment right now. Just change it to the div. Oh,
here?
Yeah.
Oh, can I do a class in here?
You put it as a div first.
Oh, yeah. I have to do another div, yeah. So you're a front-end dev, I'm not. Okay, I'm not going to bother with that right now because I want to rather show you the functionality, but you get the idea. You can start making you can get this guy on your team, and you can make an awesome app. Or you can hire me, and then, it's just going to look like this. Okay, cool. So you get the idea though. We have this kind of connected address now. We have this buy now button, which doesn't work. But maybe we want to do an input. So let's do, yeah, let's see, what can we do here? Well, first of all, let's say we want to update the greeting from this thing, right? We come to scaffolding, we go to the docs, we have this balance component where we can get like a balance. So maybe we want to grab the balance just of the wallet as well. So we could say like import balance. Actually, I can just do it like this. A lot better. And then we can say balance connected address as well. And we get the balance. There we go. So now we know how much ETH this guy has. Again, very ugly. You better CSS than me. Okay, and then let's say we want to create a thing that allows me to update the greeting. This is where it gets a little more complicated, but then we can go to the hooks. Okay, so first we want to know what the greeting is. So we have this use scaffold read contract. So what we can do is grab the code, the example here. This will allow us to read from the contract. So we can say we want to use scaffold read contract. If you're using VS Code, you can just do quick fix and then import, and it will import it above here. We want to do the greeting, and we don't need to pass any arguments. We can just do it like this. We can actually, I think, just get rid of the args like that, and that should work. And we will call this current greeting. And then now we can put the current greeting. See if that works. Cool. Now we have the greeting. Now we might want to add an input to update the greeting, right? So let's go back here. We have the write contract for that. So if you want to read from the contract, you go here. If you want to write to the contract, well, here it is. So let's say we have, in this case, if we don't want to do anything crazy like having an input field and then using state to like add some input to a field, we can just make a button that will just update the greeting. So let's just do that. Let's just copy this, and this will kind of walk us through. Oh, first we need to do this. So we need to grab the import, which is going to be right here. Again, it's going to tell you that this is not installed. You can do quick fix, update the import, and it will add it up here. So now we have the ability to read from the contract and write from the contract. And now we can make that button there as well. So we can grab this button. Now we can replace the button that's here with that one. And let's just save it. But we don't want to send any ether actually. We can just do value. I don't think we can just get rid of this. Oh, whatever, what was it there? The value to set. So what do we want the greeting to be? House of Web3. Normally you probably have like an input here where someone can like come in here and like change it, right? But I'm just trying to show you how the button works. And then we say like house. Save it. Okay, cool. So let's see if that works. We're getting this parse ether error. We need to import that, which is available from VM. And it's save. So what this is going to do, it's going to give me a button. It will change it to House of Web3, and it will cost 0.1 ETH to do that, and that should get deposited in the contract. Let's look and see if it works. All right, boom. And did it work? Yeah, it worked. So you get this idea. You start building out and testing what you're doing with your smart contract, deploy the changes, then start building out your UI. There's lots of stuff in here you can do. You can listen for events, but that leads me to my next part, which we want to actually show off this subgraph stuff. We haven't really gotten to that. At least now you have a basic understanding of how you write your smart contract and how you can read from your smart contract and write from your smart contract or to your smart contract. You can kind of get around in here and see that there's some inputs that you can use. There's an address input with ENS resolution, which is really cool. If you use that, you qualify for the ENS bounty. Just saying. There's a blocky avatar, which is really cool. It fixes the little icon. There's read and write. There's events. You can also get contract deployed info from another contract. So there's lots of cool stuff in here already out of the box. And you can also interact with an external contract as well. I'm not going to show how to do that, but if you want to, you can add an ABI for other contract, and you can call it from within scaffolding. There's also a bunch of recipes here. So take a good look at the docs. The docs are really good. There's also a Telegram channel that's available in case you need help. It's down here on the corner, right here, Telegram. But I will be around as well at the hackathon, so feel free to flag me down. Okay, so now let's talk about the subgraph. Okay, so with very basic context, I just want to talk about like why you need the subgraph. He's going to go into way more detail about this, but basically when it comes down to it, is somewhat difficult to do, especially if you want to get lots of information, or if you want to get specific information at a point in time, or if you are trying to get information from like a wallet or like something that is not necessarily available in an event, right? It can get very complicated pretty quickly. And that usually ends up in lots of RPC calls, which makes your front end kind of slow and clunky. And so the idea is that we want to use the graph, okay? So the graph is a middleware layer. It's like a decentralized network just for blockchain data. Now this subgraph extension comes with another folder, right? We've messed with the back end, we've messed with the front end. Let me just minimize this stuff. Now we have the subgraph. Now the subgraph that comes with Scaffold-B subgraph extension already is available and works with the existing contract, okay? And we can take a look at, actually I think maybe it might make sense to just show a little diagram real quick. Let me do that. Let's see if I can go to slides. Here. And I just want to show one slide. This is from another talk that I gave. Let's see. There we go. So basically, a subgraph is 3 files. Okay. So you need a manifest, which is like a high-level configuration file that kind of points at what network you care about. It points at the events you care about. So basically, it says like, well, this is the ABI, and these are the events that come off that ABI, and it references the schema, and it references the assembly script mappings, which is all written in assembly script, which is a subset of TypeScript. So if you know TypeScript, it's very easy to use. But the idea is that the manifest is the high-level config file, right? Then you have the entities, which is like how you want to query the data in GraphQL. So the graph, one of the core things about the graph is it stores all the data in Postgres, but it allows the user to query the data over GraphQL, which is really great for front end, right? And it's really great for getting large amounts of data that you might have complexities by querying the RPC directly. So the schema keeps track of how you want to store the data and query the data. So like what kind of data types there are. If you think about like Ethereum, there's address data types, there's strings, there's unsigned integers, there's booleans, right? The entity keeps track of all of those data types and how you want to store them and access them via GraphQL, right? And then the third one, and by the way, this is like a speed run of this stuff. He's going to go into way more detail. And the last one is how you want to process the data. So you can think of it like as the events come off of the smart contract and emit data. I didn't really talk too much about events, but if you know what an event is, it's basically a log, right? It's like a log for your front end to know what's going on and to notify anyone on the blockchain, right? That something changed, like state changed on your function or whatever. So what this assembly script does is it's a WASM module that's compiled down and runs as a WASM that is written in assembly script that takes that event data as it comes off and stores it into the Postgres database in a format that's accessible with the schema. Does that make sense? Any questions about that before I keep going? Because this is always like where it gets a little murky, people are a little glossy-eyed. No? Does that make sense? Cool. All right. So then the events come off the event, the chain, whatever chain you're on. We also can query and get off-chain data, so like IPFS or Arweave. So we can let's say it's an NFT and it has a hash from IPFS. We can also go out and get all that data from IPFS and store that in the graph as well, which is really powerful. We do all that with the subgraph, and we store that in the database. On the indexer store that. And we basically then allow consumers to consume that data, right? So they do it via GraphQL. They make a request. The graph node, which is written, it's a Rust implementation, goes and basically finds out how to get the data from SQL and then provides us a GraphQL response. So it's kind of a middleware. It's like a middle layer for blockchain data, right? And so this is kind of what you end up with. You end up with the dApp that you normally would write, like we just did, but you still propose transactions to the blockchain. You still are incentivized to use that blockchain for its security, for the gas, everything you use. The smart contract emits events, and those events come off and are processed using a WASM module and then stored in the database and exposed to GraphQL. So this way your dApp can just query the GraphQL API. It can make one simple HTTP request to get all the data it needs, and then process that stuff and expose it in the UI. Okay. Yeah, he'll go into much more detail, but I wanted to give you a very basic primer of how that works before we set up this next thing. Okay. So we have this subgraph folder. Now, what we're doing here in this subgraph folder is we are emulating the Docker, or we're emulating the graph node stack inside of Docker. Okay. And so we're going to deploy these config files to that Docker environment. So let's just get that set up real quick so I can show you guys. So if we go again to localhost 3000, we can go to the subgraph tab, and we can tell exactly how we need to set it up. Everything's here. We do yarn run node first. So let's come over here to this fourth window that we have. So we're going to use this one for deploys, but we're going to use this one for our Docker. We do yarn. I'm just going to do clean node real quick, which cleans up any old files. And I'm also going to do yarn stop node just to make sure that those containers are dead. Yeah. So, but to run a new one, we do yarn run node. So clean node cleans up any files on the folder. Stop node stops the containers. Yarn run node starts the containers. Now, you don't need to understand Docker, but the basic TLDR is that these are like virtual machines that are running inside of Docker containers. Okay, so Docker is just like a virtualization kind of, it's containers, which is a little different. It's Linux containers, but they're just simulating what it would be like if you ran this stuff on a server, right? It gives you a lot of flexibility. So we know that everything's working when it says downloading latest blocks from Ethereum. You see that? You're golden. We are basically running, in this implementation, we're running graph node, we're running IPFS and Arweave all together, or sorry, IPFS and Postgres all together. Okay, so we know that's working. Now let's go back here. What do we need to do? Well, we need to run local create. So the first time that you set up the graph on this subgraph, you create it. So let's do that. That was successful. Now we can ship the subgraph. Now I'm going to ship it, and then I'm going to come back and show you afterwards what the config files look like. So let's take it. So again, it comes with one that works perfectly with the contract that comes with scaffolding. So we don't need to worry about it. We can do that. 0.01. So this is the version. So what's happening here is we are getting the ABI from Hard Hat or Foundry. We're copying it over into the graph subgraph. We're checking all of the types that are basically built and created to make sure that they'll work properly with the ABI. We're doing that by referencing the schema and making sure the data types match. And then we're like compiling down this WASM module, and we're pushing it with all of the configurations to the graph node. And so this is a kind of a deployment script, but it's using the CLI to do this. We have this command, a yarn command I just typed that just kind of shows you. I'll show you how to reference that later, but it's asking for a version number. So it's kind of like when you make changes to any kind of software, you have a new version, right? Same thing goes for the subgraph. As you increase your version of your smart contract, you also need to increase the version of your subgraph. So I'm just going to use 0.0.1, which is the very first version, compile it, it deploys it, and then it gives us the URL for it. Okay, so if I grab that, it gives us a GraphQL, GraphIQL window. And this might be hard to read, but let's take a look. So it tells you exactly welcome to GraphQL, But what's cool is here, Explorer. We can see the data already here. We have greetings and senders. So give me the first 10 greetings, order by ID, we can order by the timestamp that they were created. We can get the greeting, the ID, the premium that was paid, who the sender was, what their address was, and what was the transaction hash and the value. And now I can hit play, and I get that data back. So we can see all the changes that I made that are here, which I think is just maybe a couple. But if I come over here and make another change, let's go ahead and do it. Let's go to debug contracts. Oh, let's set it here. I need money. Funds. Boom, 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 boom. I'll just set a bunch, right? Just send a bunch. I just spam the blockchain, you know? Okay, so now I can hit play again, and then we'll start getting all that data back, right? So it's processed in real time. this section just so we can see it a little clearer. Let's get rid of all this other stuff. We don't need to send it. See if we can get them all. There we go. So we got all the changes that we made. So this is really useful because before you would have to query the RPC directly, and if you wanted to know like the greeting like it was sent yesterday, you might have to reference like the exact hash or something like you end up having to index the data yourself, and so the graph just solves all that, like taking care of all the indexing. Okay. Now, one last thing I want to show is the config files and how they work. He's going to go into way more detail, but the schema, the subgraph YAML is here. It's inside of the subgraph folder. Tells us what networks we care about, and the last one is the schema, GraphQL schema file. Again, this is how we want to store the data, and then the mapping. Those are both inside the source folder. Okay. Marcus is going to talk a lot more about that. But what I want to highlight real quick is how we use this GraphQL now, right? How do we get this rendered in our front end? So if we go back to the packages and go to Next.js, there's a subgraph thing here, and there's a subgraph page, which is what we were referencing earlier. And there's a component, and it's a greeting table component. You'll see here, this is an example of how you use what's called Apollo. Apollo is like a GraphQL query framework that allows you to query GraphQL. So what we do is we use that package to use the query, which is the GraphQL query that we use here, right, in this window. If we were to copy this, we would get the same data that we cared about. So I could copy that over here, paste it, and play. There we go, we get that same data. So this is the query. We create the query, and then we formulate a request using useQuery and GQL. So it's kind of convoluted, but this is how you do it. And then you can set up like fetch policies or whatever, GraphQL stuff. Your front-end dev will know all about that. And then here we see if there's an error, and otherwise we store the data in this greetings data. And so there's a table that shows you how to render this data. And neat trick, use ChatGPT if you get lost here, because it will like do this for you like so easily. You just give it the schema, and you give it like your code here, your TypeScript, and say, hey, this is my schema. Why is my data not rendering? Give it this, and it will just fix it for you, and your data will look great. But if we go back to scaffold E and look at that, it's right here. So subgraph, and then it's right here on the bottom. So this is a very beautiful table of all the data, and you can display all those greetings here inside that data. So it's a good reference if you're writing a front end, like how you get that data and render it in the front end. Okay. Cool. I think we hit 40 minutes right now. So maybe we have like 5 or 10 minutes of questions if there's any. And I know that was kind of a speed run, but it's kind of designed that way because you can't really learn everything by just following along with me. But hopefully you get a good idea of how to do most of that stuff. If you want something to look at, you can go to bit.ly/fullstackdapp, and there's a walkthrough of this, step by step, how to do this. So this is great. It's on my GitHub. It's kmjones1979. So if you come here, again, it's bit.ly/fullstackdapp, and it will walk you through all those steps that I just did and show you how to set up your subgraph, make changes, and do your testing and all that stuff very easily. So cool. Thank you. What kind of questions can I answer? Does anyone have questions about the graph or scaffolding? Yeah.
So if you wanted to use scaffolding with, say, a layer 2, how would you do that? Like, it's probably different for each layer 2, though, right?
Yeah. So if you go to thegraph.com, he's going to go into more detail probably of this. He'll probably use, I don't know if he's going to use scaffolding, but he will talk more about the studio. I'll just briefly touch on it. There's the subgraph studio here. You can create a subgraph on any of the chains you support. You just sign in with MetaMask like this, or whatever wallet you want to use. And then you can create a subgraph here. So you can say, okay, create a subgraph on my app. This, create a subgraph. And then when you go there, click on it. You can install the CLI and then do the init. So this is going to bring up a thing that's going to ask you exactly what chain that you want to reference. So all the chains that are supported are going to be there. There's like 70 plus chains. So if it's a layer 2, you just find it there in the thing, say Ethereum, what chain it is, put the contract address for the contract you want to index, and then you can start getting the index. It will actually build out the subgraph for you, which is really cool. just do like the graph supported networks? I think there's a page for that. Yeah, here we go. All the networks are supported are on there. Cool. What other question can I help? Cool. All right. Well, we'll hand it off to Marcus here in a sec, but thank you so much. Appreciate you guys. And yeah, you go do it.
We'll take like a 5-minute break if anyone needs to use the restroom, and we'll get going. Yeah, just 5-minute break right now. Yeah, restroom, water, whatever we need. Are you from?
Yes, we have a system for this place.
You guys are happy? Are you in the Oh, you need this one. Bye-bye. See you later. Yeah, sorry. No, I'm a speaker, so.
I mean, the issue we're getting a text information of use is using some.
Yeah, we're gonna chat. No one chatting right now. What else you been doing?
So, like, the way to represent them.
The scaffolding is really cool.
Oh, thank you.
So you're one of like the core devs for that?
No, I'm not for that, but I do help here and there with support requests, but no.
No, I mean like in my project, like I set all that stuff up like by hand is such a pain.
I'll just hang out here for another minute, see
So,
what people get
like,
back.
so easy.
We're gonna be getting into more specifically the graph, subgraphs,
So I mean, I love
and learning how to. So, who here has been to House Web 3 before? Yeah? Big fan of this place. Okay, let's just get going right now. We'll let people focus back in when they come in. First off, thank you, Kevin.
Thank
for your presentation.
Thank you.
And we're going to get into here at Hackathon, which registration starts with 2 hours here. And I want to hone in everyone's focus as much as possible on not only using the graph, but also being focused on what we're trying to express to you guys and saying, hey, here's the tech that we're building. Please use that tech in an awesome way. And that's essentially what we're trying to do with you guys, and I know you guys will. So let's talk about the prizes. There's best used subgraph, which means that you guys will be deploying your own custom smart contract with its own logic, and then indexing that data with a custom subgraph, because that subgraph points to that new smart contract that you guys have so elegantly built. Here are the prizes for that. And then best use of a subgraph. With the graph, there's 9,000 subgraphs that are already published, 9,000 plus, maybe even 10,000 now, which is cool. Yeah, there we go. 10,000 subgraphs on the graph network, which are subgraphs, in case anyone doesn't know, decentralized API. So you're able to plug into these APIs that are decentralized, and that is blockchain cool. So this is best use of subgraph. If you decide for whatever reason to build a custom smart contract and a subgraph, and then also use someone else's subgraph, you can qualify for both, because that would be a really, really cool application. So get creative. Right? Look at what else other people have built, and then also build something cool too, and really double down. And finally, best substream. This is a relatively new technology that I'm still learning right now. I can't speak super well about it, but essentially, if you would like more than event data, you should use a substream. That's big summary of what a substream is. There's so much to talk about that, but essentially, that is a substream. It is giving builders more data than event data. That's a huge summary. There's much more to it than that, but we can talk more about that later. Any questions about those three prizes? Because we're going to be focusing on those three. We're good? We're good. Cool. Let's get into it. So we're going to start with a high-level understanding of what the graph is, and then also pointing that to using subgraphs that are already in existence. And then we're also going to build a custom subgraph together. So if anyone wants to build with me, this is the time. We have time today to hang out. So we're going to do that. For the repos that I'd recommend you walk away with, if you just want to query existing subgraphs, this is a good repo that I built that essentially allows you to just drag and drop the code in with these frameworks and libraries and just put in your own API key, and then you can start querying subgraphs on the graph network. You have 100,000 queries per month that are free, so that's awesome. So you can query production subgraphs without having any charge to you. And then another repo that a friend built recently, who is an Uber front-end builder, built this one, which supports all of those ways of querying the graph. And that's Chris Whitted. Anyone here knows Chris? You know how good a front-end builder he is. And so yeah, we have two different repos here. If you don't have those, you haven't scanned those, no worries. I'll be able to get that to you later. So let's get into the high-level overview of querying data with the graph, and then we'll actually build our own custom stuff. So it's not the answer that enlightens, but the question. If we are here in Web3, we have a lot of questions, I believe, for society, for the world at large, for financial institutions at the world at large, and having good questions and then providing those answers. That's a blend, curiosity and tech. Right? You have to have the curiosity is fuel, and the tech can be the answer to data. So let's get curious, let's think about different ways that we can ask good questions and then have that tech be of the graph. Really quick overview, high-level overview of what the graph is doing. The blockchain itself is write optimized, so anyone that wants to write data to any blockchain can. It's highly disorganized, and so we need to index that data. And if you do that, that's great. We have index data that's organized in performance and can populate to a front end rapidly. Yay! However, there's a lot of Web 2.5 solutions out there that do that in a centralized fashion, essentially taking the use of Web3 and neutering it, saying, hey, we've got decentralization kinda. And decentralization kinda isn't the direction I think decentralization wants to go. I think decentralization, yes, is the way decentralization wants to go. And so the Web3 read solution provides decentralized indexing with the graph. And the graph is decentralized indexing. There we go. Oh, full screen. I'll be hopping around. So this is, yep, thank you. The Web3 read solution is the graph, where there's indexes around the world providing decentralized data organization at scale. So that is the graph. Real quick, 100 indexers, plus 100 indexers worldwide, and fast, cheap, and affordable. It's $38 for manual queries right now, which is competitive in the world. So that's that one. Let's go into subgraphs. Who here has built a subgraph before? 1, 2, 3. Okay. Who here has never built a subgraph before? Cool. Awesome. All right. So we're going to be talking to you guys. Subgraphs are APIs. APIs are subgraphs. Who here knows what an API is? Who here doesn't know what an API is? That's okay if you don't. Cool. Awesome. So everyone knows what an API is. All right. It provides an endpoint that you can go ahead and get data from in a nice organized way. Subgraphs are the Web3 version of APIs. They are customizable, highly customizable. You can do a lot of different things with subgraphs. There's tons of features with them. And then also, because this is a Web3, Subgraphs are valuable. They exist in the marketplace. There's a token that's working in the graph all the time called GRT, and it provides value to certain APIs, more or less, depending on the quality of data and organization of data. Pretty cool concept, but essentially that's what the graph is doing every day. For the visual learners out there, this is my favorite GIF of all time. It's GIF, not GIF. Anyone says GIF, I'll be angry. So no GIFs. But essentially, this is what it's doing. It's taking disorganized blockchain data and putting it into a nice organized database, and you get to design that where the data goes. And that's what Subgraph is, the API. Okay. And here is how those balls kind of are flowing, if you will, for that metaphor. Keep that metaphor going. Kevin talked about the manifest, talked about mappings, and talked about the database. This is the way I like to look at it in terms of the file structure and flow of data. We have on-chain as well as off-chain data. We can index from IPFS and Arweave as well. And we get that on-chain data, and then it goes to the manifest. The manifest is kind of like the high-level overview. That's the file. It's a high-level overview of what your subgraph is doing. It doesn't really give it a whole lot of information at middle level, low level. It's just kind of saying, hey, this is where we're pointing our subgraph at. And then once we point our subgraph at the data, we actually do some stuff with the subgraph data. This is the transform. Anyone know ETL, transform load? This is the T. This is the transformation. So we're kind of pointing here, we're extracting, we're transforming, and then we're loading into the database. The database is the schema.graphql. So ETL, that's kind of a high-level overview of what each of these files are focused on doing. Does anyone have any questions about this file structure? Because we're going to be going into this. Any questions? Yes.
Sorry, the L at the end, is that running, is that running on a user's, where does that run specifically?
Great question. If you're building with Kevin's scaffold ETH, you're running a local database, a local graph node, and it's actually on your computer. If you're going to be going through the graph itself, you're going to be having that actually on a, depending on if you're on the network or not, somewhere else. So, yeah. Any other questions about this? We're going to dive in more on this. So this is super critical we get this first. Cool. Okay. So, and then not only are they customizable instructions, but they're also valuable. Like I said, they exist in the marketplace, and we'll talk about that kind of marketplace as we get into this more. So that's the graph, high-level overview. 100 mixers worldwide, all permissionlessly indexing data. Each of them their own little businesses. Think of them as their own businesses incentivized by GRT. 70 plus chains are now being indexed, and there's 9,000 plus, I think almost 10,000 plus now, decentralized APIs known as subnets. So let's go ahead and do this. Is anyone here going to be going along with me? It's okay if you're not. Yeah. Okay. Cool. We got one person going along. Let's go ahead and get set up to query a subgraph. This goes down the prize pathway of the right here. We're going to be first going down the best use of subgraph pathway. We're going to be saying, hey, we're going to look for a subgraph that's already built, and then we're going to send some queries to it. It's already organized, it's already extended, it's already got a lot of features. This is the pathway first, and to do that, we're first going to have to get an API key. We're then going to find and assess a subgraph on the Graph Explorer, which is where all the subgraphs are. You can search through them. We'll design some queries. We'll say, hey, what are some good questions to send to this organized data? And then if you'd like, you could actually integrate those queries with your DApp. And from there, that DApp could be Kevin's scaffold ETH, where you have essentially the front end, you've got a smart contract, and then you can send some queries, pull back, and you actually have this nice little dovetail. See how that works? Yeah? Okay, so let's go ahead and do that right now. We'll do graph.com, and let's go ahead and go to Subgraph Studio. If I'm going too fast, just let me know. Totally fine. At the top, you'll see API keys, and then you'll create an API key, and we'll call this thing House of Web3 Live Demo key. And a few things that you would like to do here. I think they're cool features, period spending limit, and then spending limit USD. If you're going to be worrying about querying more than 100,000 per month, enable that. That's going to be nice just for you. But like I said, 100,000 is free every single month. And then one of the things I always like to highlight is security on this API key. use the security that's baked in. You could authorize only select subgraphs or a singular subgraph to use an API key. So if for whatever reason the API key gets taken, guess what? We're good. Only one subgraph will be able to use it. And then also authorize only to a single domain, or multiple domains. So it's just nice security for you guys. So if in any case, for whatever reason, that API key has some type of security violation, you guys have it. So that's it for the API key itself. Now that we have an API key, we can start sending queries to live production subgraphs on the Graph network. So let's go ahead and do that right now. We'll go at the top here from Subgraph Studio to the Graph Explorer. We can explore all the 9,000, nearly 10,000 subgraphs of the Graph network. So here we are. We've got a lot of subgraphs, and we'll just look. You can see live data and seeing the queries over one day and the signal on this. And real quick, with signal is the amount of value that people in the marketplace believe this subgraph has. So if people in this marketplace believe this subgraph is well-organized data, it's being used a good amount, 37 queries in the last 37K queries in the last day, they're going to put a little GRT on that, and that shows up in the marketplace as higher value. It actually ranks a little higher. So you're seeing a marketplace existing based on open data and then open marketplace, and being able to actually value more data and as they. Is that me?
It's might need new batteries.
New batteries. All right,
Yeah.
that's okay. And so that's kind of a high-level overview of how first you can begin to assess the quality of a subgraph. Like any open market, it is one indicator of a subgraph's value and a subgraph's data. Let's see, this one's getting 3.3 million queries per day, which is great, and has a lot of signal on it. This one, 4.7 million queries per day, 3K signal on it. These are typically going to be higher value, more organized, nicely organized data sets for us to start building with. Does that make sense to anybody? To everybody here? Being super clear with that? Cool. Data marketplace. Now, that's the first way that we can assess, is this data valuable? Look for the level of signal on it. Look to see if that's good. The next thing we can do is go one level deeper and say, hey, is this data being organized in a standardized way? And there's a team on the graph that's building on the graph called Masari, and you'll actually see these little tags here. See that little black, you can see it on the screen here, that little Masari right there. Masari, I always look for Masari tags on the subgraphs. Let's see if up here, down here. But essentially, this is another very good indicator to indicate that there's been a system and a dedicated team that's built over 700, maybe 800 subgraphs that is using a standardized database schema. Now, who here has sent queries to databases before? Yep. Wouldn't it be nice if like 150 or 700 databases all were standardized? Wouldn't that be nice? Masari did that, okay? So if you see a Masari tag, you know those databases are standardized, and if you send one query to one under the same type of database, they have different types, we'll go over that, that exact same query should work on another database of that same type, okay? So does that make sense? Yes, cool. Let's go ahead and see what those types are. Subgraphs.masari.io, and we can see their dashboard of all the subgraphs that they are currently working on, what state they're in, what version they're in. You know, they're always updating them all the time, so it's quite a voluminous dashboard. While that's loading, any questions so far about this? We're doing good? Cool. Loading up. But yeah, I always look for, first I look for the amount of signal on the subgraph, and that's the GRT, how much signal is on that subgraph in terms of the marketplace's valuation. And then I look at if it's a Masari subgraph or not. And these are the different types of subgraphs with a bridge. And these, if you send a query to any one of these subgraphs, it should be able to be sent to multiple subgraphs, multiple endpoints, and get that same data back, which is very nice. Then another big type is the exchanges. There's lots of decentralized exchanges out there. So look at all of these exchanges. My goodness, we got a lot of them. Wouldn't it be cool to send one query to like 20 exchanges? That'd be pretty cool, all right? So one thing you should do before you send a query and be 100% confident with it is look at the versioning of it. A lot of times the queries will work across different subgraphs under the same type, but sometimes the database schema is a previous version. So if it's for whatever reason isn't working, it's a little frustrating. That's the reason. All right, if you're seeing just different, because they, the people too, they got to work on each database and update them accordingly. That's part of the work. So try to send queries to a near similar version to have that same query work across all databases. Cool. So that's the next thing I look at to assess, is the subgraph worthy of my time, of my queries, of like, all right, do I really want to build on this? I first look at the actual signal. I look to see if it's a Masari subgraph, and then I go another level deeper. So let's go another level deeper. The first subgraph I ever jumped into 5 years ago now, 4 years ago. That's when I had more hair. Was this one right here, the CryptoPunks subgraph. So the next thing I like to do is actually go into the subgraphs dashboard and take a look at the subgraph itself. Subgraphs are permissionless. Anyone can build a subgraph. Anyone can publish a subgraph. So because anyone can do it, there's various levels of quality of the subgraph. You might have some subgraph that's incredibly extended, lots of features, and some that's not. With this, let's just do a quick overview of this dashboard. You can see with this subgraph, there's 2 indexers indexing this subgraph. There's a little bit of signal on here. So decentralization already baked in. You can see the indexers on there. It's a nice little dashboard. But the most important thing I like to look at is the actual metadata of the subgraph. Quick question. Yeah. Question. Oh, there was a question. Oh. If anyone has a question, just throw your hand up. We can have a chat. I like to see a subgraph developer contributing to this ecosystem with good metadata. And that means the subgraph is searchable. That means there's actual documentation to the subgraph. That's just nice to have a developer experience that is respected by another developer. So I just look to see, hey, do we have tags here? Do we have a good little bit of metadata here? Let's actually go to the GitHub. The actual developer said, hey, this is our code. Feel free to jump in. That's always very nice. Is there documentation? Oh my gosh, this subgraph developer is taking the time to actually put a dang README in there. Sometimes that doesn't happen because it's permissionless. So look for the READMEs, look for good, like, okay, this developer knows what they're doing, they really care. Let's go one level deeper, okay? Let's say, all right, what would a good subgraph developer do if they were developing? They would write the comments in their actual database. Let me make this bigger. They would say, man, we're creating all of these different entities in the database. Wouldn't these entities be nice if they were explained in plain English? And as you can see, in this one, they have. This subgraph developer has put in plain English. When you send a query to the account entity, is the ID, what is the ID? Is it just going to be a random string? Is it going to be, who knows? They actually say, hey, this is going to be their Ethereum address. That's so nice if you want to build on a subgraph to actually have comments anywhere. So that's kind of the way that I go down to assess the quality of a subgraph. If I first find a subgraph that's going to, first a community I like to see how much actual signal is on the subgraph. I then actually go one level deeper and say, all right, cool, do I actually have a Masari subgraph or not? If it's Masari standardized, I'm going to organize that. I then go look and actually see the metadata, the documentation, is that good? And then finally, I go to the schema. Okay, and then from there, I have a good idea that this data is valuable and I can understand the data all the way from chain to query. Any questions on that pathway? Yes.
About the liveness of the data, is there a way to check that too?
Yes, I mean, you can see if the subgraph itself is at chain head or not. So let's go back. And this one right now, if you hover the mouse right over progress, there we go. Current block and final block. Where the block is, where the subgraph is indexing, is at 4270, and the final block of the chain is 4271. So one block behind. So pretty fresh. And if you want even like faster syncing, like there's some teams that want like the literal fastest syncing, that's a substreams that we'll talk about a little bit. Giovanna, excuse me, we'll be talking about substreams a little bit, and that's like literally like the most. So that's gonna be good. So, but we'll just stay with subgraphs right now. Let's go into how we can learn a little bit about sending some queries to these subgraphs and learning about the kind of extending our subgraphs. Now we're getting into subgraph development a little bit here. Who here is going to be writing a custom smart contract? Custom smart contract? Maybe? Okay. Okay, cool. So this is where start paying attention a little bit more, because this is how you can learn how to do interesting transformations with subgraphs. And you can use ChatGPT, you can go ahead and compare different subgraphs. Like, this is a really cool next step to blend everything together. So let's go into the code again and say, all right, we know where that database is looking. We know how it's looking here. We know where it's ending up. We know where we're sending our queries to. Now, what about if we're going to be doing just the most basic subgraph possible? It's not going to have any of these links, any of these derived from. It's not going to have any of these comments. It's literally just going to be pulling event data directly from the smart contract. By the way, subgraphs are optimized for event data. So think about event data and write that event data into your smart, emit that event correctly from your subgraph, from your smart contract, as you're writing your smart contract, because then your subgraph will be optimized for that event data. It's really critical. So have that event data being emitted, you're not going to be getting all of this nicely organized information. You're simply just going to be getting the event data. So let's go ahead and build a subgraph right now that goes to the exact same smart contract, CryptoPunk smart contract, and see what that graph init, just initial code-generated subgraph, looks like from the basics, and compare it to this one that's highly extended. It's just going to be looking at the exact same smart contract, and maybe you guys can connect the two. Say, hey, we have one that's very baby, it's a beginner subgraph, and we have one that's very extended, and you can see all the features in between. Does that make sense for a little learning journey? Yay. All right, so let's go ahead and start building our subgraph together. All right, graph.com. This is the part where we're going to do some live coding. So if you want to do that with me, go ahead. Yes.
Just a really quick question. Does subgraph have any, like, does it worry, how does it handle the index thing with the events? Like, if the parameters indexed or not, does subgraph care about that?
If the parameters of the index are gone. I don't understand the question.
So like in the event,
Yeah.
you know how you can have indexed or non-indexed?
Yes. Yes.
Does the subgraph worry about that? And then two, as the user or developer of a specific subgraph, do I need to worry about that?
I'm just writing any event in there, and either way, it's going to grab the data. Yeah. Good. So let's go into it. So go to graph.com and products and Subgraph Studio. This is a studio where we can build subgraphs. And we're going to go ahead and create one. Here we go. Subgraph name, CryptoPunks House of Web3. And we'll create this subgraph. So we'll go into the subgraphs dashboard. And if you haven't already, npm or yarn install graph CLI, and I'll do that with y'all. Is that too small? Make it a little bigger? Sure, go back. Yeah, Subgraph Studio. And then you'll create a subgraph. And then once you've created it, it shows up down here. And then you'll enter the subgraph. Cool. All right, so now we're on the subgraphs dashboard. And this is where all the metadata comes in. We're not going to fill that in because we're not going to publish this to the Graph network. This is all free, by the way. If you're hacking and you're not publishing to the Graph network, you will get an endpoint that's all here. It is centralized, not decentralized. It's just meant for development. It's rate limited. It's small. It's great, but it's not full production. So we have npm installed. And then from there, we're going to initialize the subgraph. So just copy that from there. And we'll go net. Now, this is where Kevin, where he was building locally, remember that? He was building locally and he had that local node right there. You can point that scaffold ETH to this location that's on the graph. So eventually what I would do is I would start with the scaffold ETH and build out and get your smart contract right in that local environment. And when it's ready, go ahead and publish, not publish, but actually use the studio to get your subgraph, which you've already built from that local scaffold ETH environment to this environment. Does that make sense? Okay, if you have any questions about that, let me know. But build on scaffold ETH until you feel confident, then go ahead and use the graph. Okay? So we know CryptoPunks is on Ethereum, so we'll use the protocol Ethereum, and go ahead and use the defaults here. We have a subgraph slug, default, directory, default, And then we have a list of all the chains. CryptoPunks itself is on Ethereum mainnet, and it's just called mainnet here. So we'll select that. Now, this is where we find our contract address, okay? So when you guys are doing your builds on test nets, this is where you put yours in when it's ready. We're just gonna go find the CryptoPunks smart contract address. And there it is, right there, always in DVD. And you can also confirm it. You'll go to EtherScan, there it is, DVD. And we'll hop in and drop it in. Copy paste. Keep on following around with CryptoPunks is probably the easiest to do here. Start block. You want your API, your subgraph, to start indexing not from Genesis block 0. That would take a long time. You actually have it indexed from the point where the smart contract was deployed. And that's where it is. It automatically populates that. So populate that. It pulls in the contract name, EtherScan. Now this is the cool part. Where you have this, index contract events as entities. Every event that you have emitted from your smart contract will be converted into entities in the subgraph database. That's all we're doing here. And this is the coolest part of the CLI, it's true, that's my favorite part. This is the scaffolding. It's saying, hey, there's an event emitted, at what timestamp was it emitted, at what block, what data is in there, pull it into the database, and have it be nice and organized. So, go ahead and do that. And it's going to be API. If you'd like to add more smart contracts from the same chain, you can do that. So that's a cool thing about a subgraph. If you have 2, 5, 10, 100 different smart contracts, as long as they're on the same chain, one subgraph can work. If you have multiple chains, each chain needs its own subgraph. It will work. So I just saw a question.
Really quick, do we need to add the graph package to the path variable at all? Because I installed it and tried to run it, it's not finding it.
If it's not finding it, that's if it's not finding it, that might be like a bash or a ZSCH type thing. So we can talk after this. But yeah, if it's not finding it, that's going to be like just finding where the installation is. It might try the yarn install or the npm install and try back and forth. Either one could work, but yeah, yeah. Sorry. So we'll add another contract node, and then we'll keep on going here. So we'll go back to, we've already done initialize subgraph, which is right here, and then authenticate. This is the authentication key right here. If you copy paste that, it will authenticate your local computer to connect to the graph dashboard. I've already authenticated on my computer many, many times, and also this is a live stream, so I'm not going to go ahead and put that in on the terminal. Yes, question?
I'm just curious if non-EVM works the same way. Like,
Yes, it's very, very similar. This also does Cosmos and Arweave, and substreams also support non-EVM. So if you're looking for Solana, Solana is now supported through substreams. So indexing Solana, big deal. The Solana indexing is non-existent until literally a few weeks ago. So cheers to streaming fast. So now let's go ahead and enter the subgraph after authenticating. We'll go ahead and do, and we'll just keep on going straight down. So graph code gen, graph build, and then deploy. I'm not going to do this just yet. I actually want to take a look at the subgraph with you guys and just dive into the file a little bit and then compare that to the very extended CryptoPunk subgraph that we just looked at a second. All right, and you can see what a baby subgraph looks like and the extended subgraph looks like, and then you can aspire to look like the extended subgraph. Does that make sense? Something like that. Cool. So let's go through those same 3 files that we talked about earlier. All right. That's bigger. Okay. So this is the way I like to look at how the data passes through a subgraph. You've got the high level overview. I like to look at that. This is the extract. This is pointing to the address. We got that right there. We're getting the start block that we actually have automatically populated. We get the name of the smart contract. It automatically comes in. Very nice. And then we have the mappings and the entities that are associated with the mappings. Mappings, you're looking at like the transformations. All right, what are we going to do in terms of if we're getting event data coming in? Are we doing mathematics with it? Are we combining data? Are we looking at entities and events from one location and pulling it to another? That's all the transformations. That's the mappings. And let's go ahead and take a look at what that looks like. We have the event handlers. This is a really big one here. Just naming the event handlers when the transfer, sort of a punk transfer event, is emitted from chain. The trigger, the handler is triggered. This handle punk transfer is triggered. And this is automatically populated. This is the general flow of the subgraph. An event is emitted, the handler is triggered, and when that handler resolves, it goes ahead and puts it into the database, the entity in the database, the punk transfer. So once again, let's say an event comes out of the chain, the punk offer, and this is the event signature right there. The punk offer event emits from chain. It triggers the handle punk offer handler where you can transfer the data, and then finally it goes into the handle punk offered, that is the punk offered entity. You kind of see how that goes. Trigger, handler, database. Trigger, handler, database. Yes, I'm seeing some scrunched forebrows.
Sorry, is the handle inside the TypeScript then?
We're going to get to that right now. Yes, great. Yeah, this is the high-level overview. This is the manifest, the subgraph.yaml, high-level overview. There's no logic right here. It's just naming. There's no logic. It's just saying, hey, we have a handler, and the sign event comes from the chain. It triggers the handler, and then the handler, once it resolves, goes into the database. That's all it's doing. We're just naming the names. Let's go into the handlers and see what those look like. We are right here. This is auto-generated. I always like to look at the punk transfer event. Here it is. All right, so a punk transfer event right there, boom, that's the trigger, right? It comes into this handler, and then from there, the handle punk transfer function triggers, and then boom, this runs through. A new entity is created, and then you actually get the ID put in right here. This is auto-generated. This is concatenating 2 bits from the chain, 2 parts of data. They actually have the transaction hash concatenated with the log index, which provides a nice random ID, which is just nice to have. And then from there, we are just simply taking the event from the chain, putting it into the database. That's all we're doing. We have the from event going into the entity from. We have the to event, a piece of data going into the database to. Punk index going into punk index number, or the block number, a block timestamp. This is more, every single event entity has block data in there as well. So that's just nice for convenience. But really, these top 3 are what the event signature was representing. And so you have that event, and it goes all the way through into your database. And it's one-to-one. You have a from the event, and a from to the database. 2 to 2, punk index to punk index. Very simple. Okay? Cool. Any questions so far? Questions?
Sorry, the entity like event transaction hash,
Mhm.
is that pretty standard to see that in most?
Yes, this is part. It's ideal to have the ID. I just use this ID. There's a few reasons to change the IDs, but generally speaking, this works really, really well. Unless you need to have IDs that are in plain text or something like that. By the way, if you change it from bytes, it slows down the indexing like substantially. So I like to just keep it here and find another way to get the logic that I need without changing. Cool. And then finally, that entity is saved in the database. And remember, we're looking at the punk transfer event coming from the chain, and we're just going to save it in our database as, boom, there it is, punk transfer. All right? Sitting there, waiting to be queried, nice and organized for the front end to send a GraphQL query to GraphQL. Nice. Data. So to review, let's just stay with the punk transfer. We have a event coming from chain, triggered. The handler is then triggered. We go look at the punk transfer. It runs through this. It takes the event data and populates. Whoops, see all that event data right there, and it all goes into the entity, which is in the database. The database. Cool. So this is a baby subgraph. Let's look at an extended subgraph. It's a little bit more advanced. What is an advanced subgraph developer going to be doing with this punk transfer event? Like, this is just simply taking from one-to-one and passing the data. What's some creative stuff that could be done? Could there be some relationships built? Could there be some different compute done? Let's go ahead and see. So we'll go ahead and see what our buddy here is doing with their mappings. And my goodness, we only have one mappings file. Where we have one mappings, this subgraph developer has entire folders of mappings. Okay? A lot more logic, a lot more things that this subgraph developer thought, hey, this event data is valuable. I'm going to go ahead and try to create more value by creating some relationships, by doing some mathematics, and doing some analyses, inside the subgraph itself, as opposed to doing it anywhere else. You don't want to do that on chain because you don't own the subgraph. You don't own the smart contract. You can't do that. But I need to do some compute, and I want to do that here, and then from there, populate it with that data. So from here, let's go to mapping and take a look at, there it is. Here it is. So, handle pump transfer, the event pump transfer. This is what the subgraph developer has decided. Now, I'm not going to go through every line of code. That's for ChatGPT to do. So, go ahead and look at what this subgraph developer did and why they might have done that. And then start to learn, like, oh, this is cool. This is cool. This is an interesting idea. Why would they do this with the data? It is assembly script. It is simply just going through and playing with that data, seeing what you could do, and eventually finding a good location for storage of that data. In, of course, another good thing that we like to do in the schema.graphql is create relationships in the database. That's something really nice. Put some comments in there. Like, this is really, really powerful. If you can create good transformations and good loading in that database, you've got some really, really, really cool, powerful stuff that you can do. So go through that kind of pathway. Look at the mappings, see what they're doing with the event, and then from there, see what they're actually doing with that storage of data, seeing the relationships created. It's very, very, very deep, and very, very, it's cool. You can start to play around with it. So with that all being said, what I want to do is actually get our subgraph live, and we'll just take some questions, and I'm going to pass it off to our substreams master, and then we'll go from there. Any questions?
Have you started seeing other like third-party providers for subgraph, and know what you think about them and the relations?
I could talk many hours. I mean,
So they seem to be some of the chains that don't really come on the graph.
sure.
They're centralized, right? Of course, like those things.
That's exactly my thoughts. Yes, it is a solution. It is a centralized solution, and we love our net. So if we can have subgraphs in decentralized fashion, definitely.
So they pretty much take this copycat and don't take them seriously.
We are the maintainers of GraphNode and subgraphs. So all of these copycats, they're out there, and they're it's good. Web3, getting it out there, indexing Web3 data, providing it. We've been down that path before, centralization,
Right.
and so we're trying to fight against it.
And then what about, say, projects decide to self-host? Because, I don't know what it is like if the production has a lot of query usage, of course, the project self-host.
Yes, self-hosting is always an option. It's just a matter of how much you want to scale and how much you want to worry about your index.
Okay.
Indexing is highly technical. It's a lot of work, and some small teams want to do it themselves. Go for it. But we have a dedicated, 100+ dedicated teams around the world just wanting to do the work for you, so you can focus on building. Yeah. Okay, so graph code gen, graph build, that does the type safety, and then compiles, and then we'll deploy. And we can see our baby subgraph, and from there we can see how it's indexing, and say, yay, it's simply taking the event data and pushing it into our database, and we can send some queries and get that data back. So that's really nice. Go through that flow, learn how to extend your subgraph, and then I'm going to bring it all the way around before I pass it off to substreams. The best new subgraphs, we look at that as features. Like, how many features are you using the subgraph? Are you using relationships, compute? Are you doing different types of mappings? Are you having interesting transformations? I look at that all the time when I'm judging. I'll be judging this. So go ahead and use some of these tips. I'll run through these quickly. I like these tips. Create these entities. If you're doing an NFT, if you're looking at NFTs, I like to look at, are you having an entity that's custom specific for the contract information? Are you getting the address of the contract, the accounts, the owners? Are you looking at the actual account and like the NFT? Are you getting, are you using an interface? Or do you have metadata? Are you pulling in from IPFS? Like, there's a lot of things that you can do with database management and database building. This is just some things I like to look for. Immutable events, bytes as IDs, that makes indexing super fast. Aggregation entities, we kind of talked about that a little bit, where you're getting lots of important concepts and putting it all into one part of the database. And that helps if you do your smart contract. and saying, hey, we've got all these different events, but they all relate to one kind of concept. Put that into your database. Linking entities, one-to-one relationships, one-to-many relationships, reverse lookups. Those are all getting points. I mean, that's all great. Helpers, get or create is many times assembly script like checkers, that's big time. And some advanced features that just came out recently that if you're using, I'm gonna be like, yay, that's awesome. Time series and aggregations. If any builder out there wants to do really, really, really easy compute over a time series, let's say hourly or daily, let's say they're getting in lots of different swap data and they want to see some mathematics, some sum or some high, max, min on that data, use this new feature that just came out 3-4 months ago. It's a really big one that does automatic compute with one line of code in the database. You're actually in the schema, not in the mappings, which I think is super cool. And then ETH calls, if you have to call a smart contract that you're not the owner of, you have to do what's called an ETH call, and that is relying on the Ethereum node. It's not actually relying on our node, so that just slows everything down. If you have to use that, if you're trying to get data from a smart contract that's only possible with a call, use a declarative ETH call. That feature just came out a few months ago, and that would be really, really cool too. And that speeds up the indexing. So, still a little slower, but it's and that is it. So, final thing, I like to think about the schema first. I think about the database first. What relationships do you want? How do you actually want to send some queries to? That's really, really big deal. Think about that first before you do the mappings and figure out the transformations. Like, what do you want as the result? Write that in pencil and paper. Figure all that out first, and then you can point towards that, and then smart contracts. That's it. And then I'll pass it. Any questions? Cool. Substreams? All right. We have another prize here, and this is going to be. There we go. That's the substream. Put this down, which is good. All right. Hello, everyone. So what I'll present to you today is obviously, like as Marcus already, very well did, is substreams. So let me zoom in on that stuff. So first off, like what is substreams, right? So substreams is a different approach to indexing on-chain data. It's a different use case that we saw with Graph, which is, for very high performance, low latency platforms. What do you do if you want very real-time data? So what we have is a gRPC stream. So are any of you familiar with gRPC? It's a standard. So gRPC was developed by Google, and essentially it's a way to transport information over the wire, and serialization is done in protobuf. So it's very efficient, and it gives the ability to abstract away any interfaces. So what that means is, let's say you're building a very, very performant platform like some of our users are. You can interface with the stream directly. You don't need an API. You don't need to sync it to a database. Well, you do need to sync it to a database technically, but you can interface it directly with your code. So you can write up. We have Python support, Go, Rust, and JavaScript. So within your code, you can interface with gRPC directly because it is serialized information. Now, what I'm going to be demoing for you today is something we launched last quarter, which is essentially how do we get users to build substreams faster, within 10 minutes. So we built the dev container. Now, because substreams, you have to build it in Rust, there was a lot of friction there. It was difficult for some users. Now we've made that a very easy process. So if any of you did want to follow along, you can visit the substream, you can look up Streaming Fast Substream Starter on Google, and you'll find this GitHub repo. And you can either run it remotely, or what we're
what I'm doing is I cloned it locally and you run it in VS Code. It has to run in VS Code. So I've already launched it. Just did a little code dot in the repo and launched it because it uses Docker. Docker has some problems sometimes. So I launched it first just to make sure it was happy. So this is where we find ourselves. And it actually has a nice welcome right away. And it's all this information is in the, sorry for the flipping, I'm actually going to move the chart to the side. So here, it has all the steps as well on how to get started, relevant information, what do you have to do, what are some of the dependencies you need to be aware of. Although, of course, all the main dependencies are installed in the dev container, but have VS Code installed, have Docker up to date, things like that. Now, so we're going to start, right? We're going to jump right into it, and we're going to do substreams in it. So substreams in it opens up to you all of the supports for the chains that substreams are on at the moment. So you have, a bunch of EVMs. If Solana, as Marcus, presented earlier, we have Injective, Starknet, things of that nature. Now, what is minimal versus events very quickly is if you're experienced builders already, minimal is nice because it just sets up the project folder for you with all the files, and you can start populating it with that logic that's relevant to your platform. But if you know nothing, and maybe you don't have a super advanced use case like rebuilding Uniswap, the depths, right? You go into EVM events and calls, and you can just define your my project. Okay? And actually, I'm going to restart this because what we're going to do is an example with say, because I had just done it the other day, so it's a good one to just quickly reuse. But I do want to highlight something here. So these are the EVM chains that we have supported on substreams at the moment. And we're going to focus this work like demo on say mainnet. But do note that well, actually we can go through it. So here, this is how the flow essentially begins, right? You have to pass it a smart contract that you're interested in. So like I mentioned, we'll just say, let's just did this, right? And then it's going to ask you for the API. So, if you saw right earlier before I put the smart contract in, there's a standard example that if you just want to click through, it's Uniswap. We've rebuilt Uniswap, all of the logic is in the substream. So if you just go Uniswap, it'll auto grab the APIs from EtherScan. Now, if the chain does not use EtherScan, don't fret. You just go to whatever explorer they use, and you just go copy paste the API that they have supported. In this case, we're doing an ERC20 token on, say. So let's just copy paste that API in, and that's it. Then you have to give it an initial block, right? Of course, we have support. Substreams is able to back process the entire chain very quickly. From Genesis, Arbitrum, full block, you're talking about within 10 hours, 12 hours, right? Within the day. Very good for iterating on a lot of data very quickly. So here, I'm just going to take a more recent block because, we don't care too much about seeing all of that. Where's the We'll just do these block load. 180 million. Okay. And then you have to name the project. Let's see. So here, now you get to this point, you're like, oh, do I want events or calls? What do you mean calls, right? So your typical subgraph, that supports events. So if your use case, especially at the hackathon, this is something to keep in mind, is if your use case is, I'm launching a smart contract and I just care about events, right? And I just want to query them. They don't need to be 200 millisecond latency. I just want to be able to have an API that my front end can interface with. Then bang, you want a subgraph. And on top of that, if it's hosted, you want to host it on the network, you want a subgraph. But now let's say you're building a trading platform, right? Or something of that nature. It needs to be very low latency, and you need the full call tree. What's the full call tree? For some of you may not know, that's like balance changes, storage changes, all those minute gas, all of that gas that's spent, not the gas that you pay to send a transaction, all of the minute gas transactions that are happening on chain that you don't see to execute these things. That all exists in the call tree. So that's what's exposed to you in calls, right? we'll stick to events because I'm gonna show how to build a subgraph with this stuff, but that's a very important note is if you guys want trace level data, you have to go through substreams to get that trace level data. This contract a factory? It is not a factory. Uniswap would be a factory. Add another contract. No. So that's it. Now your substreams project is built. So the code is already there. I'm just gonna do a build on it while I present to you what actually happened. So if you go into the source file, you can actually see the lib.rs. So Rust, for those of you who don't like Rust. So what's happening here is we're actually auto-generating the code for you. Like I said, we abstract the need to write Rust away. In the case of Uniswap, there would be like hundreds of lines of code for every event and every call that exists for their pool creation smart contract. Now, in the case of this ERC20 token, there are only 2 events, I think. Yes, there is approvals and there are transfers, right? So all that's happening here is the Rust code has been created to essentially extract those approvals and transfers from the chain, and it's extracting this struct. So that's your hash, index, block time, block number, owner, spender value, right? Standard stuff. But this is the nice thing here is you didn't have to do it yourself. And even more, let's say you had hundreds of lines of code of all the events and all the calls we extracted for you. You can just delete the ones you don't want. Just go and you just straight up remove it, you delete and it's gone, right? Like, and you just make that reflective in the rest of your project. Yeah, so that's all I think I care about here. Any questions so far, by the way, before I keep going? Focus, bro. So what I'm going to show you now after it's finished building is the GUI. So the GUI is like, just how you're going to see the studio was designed for testing your subgraph, for seeing the data before you publish it, getting a taste of what you actually did, and you can iterate. That's a similar thing for the GUI. The GUI is solely to test and get a taste of what you just did in substreams. So we're going to see that in a second. Again, any questions you guys have at the moment?
What's like the main use case again for substreams versus like subgraph?
So I guess like there's two ways of thinking about it. One is, well, there's 3. One is the substreams alone. Like I mentioned, you interface with that directly with your code. That's if you're trying to be very performant. Of course, you have no middleware, right? You have no API interface, you have no DB. You're just interfacing it directly with your programming language. You can choose to store that later on, but you're getting that directly right in your code. That's really if you're trying to battle those milliseconds of latency. That's where it matters. So you make things to yourself, traders, trying to do what's it called, alpha research on a lot of data. That's a really good use case there. Then you have the second case is, what if you don't want to sync it to a subgraph? You're an enterprise, you're a larger user, large organization, you can saturate your own ETL pipelines. If you're a big data analytics platform, right? Then you can sync the substreams directly to SQL, to Mongo, to ClickHouse. Those are the ones we maintain at the graph, right? But there is also, because it's gRPC and it's protobuf, you can decode those binaries anywhere. Like it's really not that much code to decode binaries. We actually have one user, won't name their name, but they decode it to Spark, right? Like their preferred way of doing analytics happens to be Spark. That's what the team is used to. So you can they stream the data into their S3 bucket and they decode the binary in Spark so that they can do analytics there. Or alternatively, you have the subgraph. The subgraph, that's how you have a subgraph that handles calls, right? And it might sync a bit faster if the contract is very, very active, like they do as well. So we can check right here. Substreams food. Again,
To be honest, I have one thing.
yes.
I always think of substreams getting just raw blockchain data too, like mempool data, internal transactions, you get everything. And so if you want to build with all of that data, substreams are really the only option.
It's a good point.
A lot of data.
So yeah, so let's go and I feel like I might have taken too large of a block, start block. I don't know if 100 million exists. Read the RPC error. Yeah, 180 million does not exist. What is their most recent block? Total holding. There's some blocks in here. The block number. Block. Oh, what is that? 100,000, 100 million. Right. Okay. Oh, apologies. We are good. I didn't authenticate. So similar to subgraphs, you will have to authenticate the substreams as well. Substreams, you authenticate it through the Graphon market. This is a common payment gateway. And you go, you grab your key, and you load it. It will make you make an account. I already have an account, so I was able to just grab it right away, but you'll make an account, you go on the free tier. Everyone, it has 1 terabyte of free data that they can process every month. Every month you get a free terabyte. That is plenty on EVM chains. On Solana, it's not so much. So let's keep moving through this. So now we can stream out some blocks. So I'm only streaming 1,000 blocks because what we really care to see here is like, it's for testing purposes. What does my data look like? Am I extracting the correct data? Do I need to change things? And there are, so this is good. You see how it's 0? It means there's no data for this contract here. Now the question is, where is it? Because the Explorer, not block 109,000. Block is there like that. I'm going to add this one. Once you've picked your start block, you can't go back in time. So I actually have to reset the project, unfortunately. But wait, okay, here, that's grab the token address. Yeah, okay. Address, API. Instead of that block number, we're going to use one where there's some activity. Token. I pick one of the recent transfers, and we'll grab this block right here. Just enter a valid block number. For confirmations. Let's do say what are you doing? Last down, updated at 1,999. Oh, I say here. Here. It's this block.
be a space to getting there.
You think? Let's check. So you get a reward. I like this guy. And then let's follow it again. You want to track? No. Good catch. Thank you so much. So we're going to rebuild that. And we're going to see what some sample data looks like. So like Marcus mentioned, it's going to be like raw data that we've decoded because the ABI is decoding the bytes, but it will be pretty raw. And then from there, what we're going to do is we're going to walk through like, your two options, right? Like option one is you can build either substreams cogent SQL, so you can send that to a SQL database that is completely available to, or the more popular path, substreams cogent subgraph. And I'm going to walk through like building a very simple subgraph with you guys. Might not be as fancy as Marcus's, but it'll do the trick. Okay, so let's try this again. So if you go to the GUI and you stream for like 1,000 blocks, now you'll see some data, right? So what you're going to see is you can see your approval. I mean, there's nothing for approvals here, but there's for transfers, right? So you can see some of that data that we extracted in the lived.rs. You can see the transaction hash, the index, the block time, the block number, things of that nature. And you can move through the chain. So we streamed for 1,000 blocks just to get a test, right? And you can see all that data. Here there is an approval, right? You can actually do a forward slash and you can do a search, and it'll search through if you have like a plethora of data points and you wanted to look for, like, trust me, sometimes there's tons and tons of events and calls. You want maybe something really niche, do a search, and it'll highlight in red all the blocks containing that one piece of data point that you care about, right? But essentially this is what it does. And the GUI, this is perfect because you can look at the data. Let's say you're building the subgraph, right? You can look at the data, you can be like, okay, this is missing certain data points that I wanted to expose. And then you can go back and you can iterate very quickly rather than going through the whole process and realizing that didn't work. So like I had mentioned earlier, you have two options to move forward, right? You have the substreams cogent SQL path, which let me show that to you right here. So you can run either of these two commands, substreams cogent SQL, or what we're going to go through today, substreams cogent subgraph. SQL is you're just sending it directly to one of the databases we support. But that is a hosted solution. You have to host it for yourself, right? Like that's a choice that you need to make as a developer of your platform. Then if you want a hosted solution, that's when you go down the subgraph route. So substreams, subgraph. And this is supposed to be a very easy process, right? So you go into the subgraph. So the point here, not saying that we won't be adding it in the future shortly, but as it currently stands, we do not cogen the subgraph code for you based off the substreams. So the goal of the dev container was Rust is very difficult for users. How do we abstract the need for them to do that? Get them somewhere more familiar to them, TypeScript or AssemblyScript, and GraphQL, right? So today, what we're going to have to do is we're going to essentially, write that. So if you go into the subgraph, well, npm install is running. Where are you? Source. Wait. And don't mind the warnings, of course. Like, I'm sure you. So what we're going to do is we're going to go into the code-r. There is schema.graphql. So the standard one, as you may know, is like the entity just has ID as a parameter. ID is a requirement for an entity's object. It's the only parameter you have to pass to it to make it happy. So that's all that we have exposed here. But now you want to add some of your own logic. So if you wanted to follow along, one of the DevRels on the team did post to his GitHub this specific project. Again, I can share it with you guys after this. And we're just going to grab that approval and transfer entity that we saw earlier, right? So very clearly here, it's not as, you're not doing fancy aggregations and stuff, but what you're doing is you're just exposing that data. Now, actually, to address one of the points that Marcus had said earlier, and to what this guy in the plaid shirt had just asked me was, what's a good use case for substreams, right? So Marcus said earlier, for subgraphs, as it currently stands, you have to write a subgraph for a specific network, right? That's how it works, and then you can mesh that together in your front end. Substreams, because they're gRPC streams, you can aggregate these streams. You can have one stream for specific data source, another stream for another data source, and just stream them together to one common point, right? You'll have to handle all of that data coming together in the sense that you don't want to mix and match different network data. But let's say you're sending it to your database, you can have a lot of control over all of these different streams of data. So you can support tons of networks as well as non-EVMs and aggregate all those together in one point, when then you can write SQL queries, things of that nature, right? And here, so this is good. So we're going to save this. I think it's in source. What's the source? Yes. So now the mappings.ts, the standard one that gets auto-generated, again, is just to make the entity happy. You generate a random hash, like with the kachak, just so that we have an ID, right? But what we care about is actually writing something. So let me just find the mappings here. Source mappings. We're going to copy this. And we'll walk through kind of what is going on here. So the nice thing is the imports are already written for you. It's the same imports that you would have had earlier. And then what's happening here is the handler is specific. You have to handle protobuf, right? So you have as input protobuf, proto events in this case. You have to decode those events and loop over them. It's like a list of bytes, right? You have to loop over that list, and then you actually have to extract from that list the data that you want. So in this case, we're instantiating the object. So we're instantiating an object entity equal to approval, passing as input the ID hash, or the ID, sorry, not ID hash, the ID. And then you're assigning to the entity, like you would do in a normal subgraph, the data that you want exposed, right? So in this case, you'd have the block number, index, transaction hash, and value. Similarly, for the transfer, you do the same thing. You loop through the bytes, because it's an array of transfers, and you assign the fields. And then you do an entity save. So it's the exact, once you get into the subgraph, it's the exact same logic, right? But you have to do everything within the protobuf decoded handler, right? Once you've decoded the data, then you can do aggregations and more logic within your subgraph. But it has to be within this protobuf handler, right? Which we call triggers. If you're looking it up on the graph docs, this is called triggers. So where are we at here? So we can save this. And now what we can do is run npm run generate. Oops. It's not saved right. We're going to do an npm run generate. And I'm going to show you guys how you can have the exact same experience to the studio, right? Show you your options here. So you have two options available to you. Either you can run this pre-written script that we have, and that can be found in the package.json. So if I click open this package.json, we have this pre-written script if you want to just run graph node locally. Some chains might not have studio support, or alternatively, some people just like running things locally. You can run a graph node locally. It'll create a GraphQL you, you can run it on the web, and you can run it that way. Or the better option is you deploy to Studio, right? So you'd run the deploy Studio command within deploy, what is it? Deploy-studio. Oh, sorry, npm run deploy-studio. And the flow is the exact same now. You give it a version name, you go onto your studio, you grab your graph auth key, you put the auth key in, and you publish. You graph publish, and it will publish to your studio account. And as you guys know, you have to match the name of the project, right? So we had named in my project say before, you have to have a my project say within your studio. And that's it. Now you're here. You have this fully synced subgraph. The reason I'm not going to rerun it is because actually I can just do a different version. So it doesn't matter. It's going to sync pretty quickly because it's a stream of data. And then you can start doing your sample queries here. So now what you're doing is you've tested your stream before, now you're testing your subgraph. Does my API make sense? Is the data I'm supposed to make sense? Right? And then you can go back and you can iterate. So it's a really nice flow of iteration that you can do very quickly. And everything is supported for it. I think I showed a lot of the nice things here. If you guys have any questions, anything you wanted to see otherwise?
Yes, kind of a general question regarding what you can do with just the substream and maybe the graph. So, like this is about like account centric versus the contact centric. Because so far, like in like our team, a lot of the problem running is like say wallet balance, the serve wallet balance, or like position holding.
Yes.
Seems like it's fairly difficult to achieve with the whether standard subgraph or substream. It's almost like you do need this post processing in the database to sum up all the transactions. Is there any like active things that the graph team is addressing this, or do we actually kind of have to do it ourselves?
So that is a great question. So wallets as a vertical.
And then you kind of look at all the providers, right? They're all centralized, like covalent and all that. It's
Yes.
simple things like this. It's just so surprising, right?
So there's a lot of great points you made in there, and you have to answer it in different parts, right? So one is wallets as a vertical. Why does the graph not necessarily serve wallets as a vertical better than they serve DeFi platforms and analytics platforms and traders? Well, people have written standardized APIs where they just have a hosted database of wallet addresses, the associated balance, maybe the associated block, and they have just pre-written SQL queries to expose it through their API. So there's that question of, do we want to have a self-hosted database to expose that data, or do we want to empower the user to just do it himself? So do you want to host your own database relevant to the wallets, relevant to your platform specifically, and you host that database, right? So that's kind of the question here, because you mentioned covalent or quick nodes or something, right? The stack is not programmable. So what they're offering to you is, like you mentioned, centralized way. They're controlled data sets that they have control over the data sets. They have control on what data is exposed in those data sets. We've taken a very different approach. We, as a company, are a programming paradigm. We empower the user to develop as his mind sees fit. And that's kind of the segue of answering your question here. It's almost a decision of, do we want to take the control over the experience, or do we want to have the user have control over the experience himself? Do we want to move away from being a programming paradigm first versus being a hosted data provider? So that's kind of the question that you're asking there. So
right, but from a use case, right, for a team to build this wallet balance without relying on covalent, it's actually quite non-trivial. Yeah. But whereas Uniswap is also non-trivial, but there's so many standard subgraphs out there you can just run.
Exactly.
So just wondering, like, there seems like a real pain point, at least we're experiencing. Yeah,
so maybe
is anything planned in the roadmap, or?
So the way I'll say it is, there is a potential future where this product may or may not exist.
Okay.
And I'll leave it like that.
Sure. So nothing in the roadmap for now, right? Okay.
R&D. But it's a very valid point. And you're right, that is a vertical that we, the graph, understand is the, out of everything we believe we serve very well, wallets are maybe not the best use case that we offer.
And then to summarize, the raw data transactions as well as just particular contract, giving all the data related to this contract.
All the data related to that. That's where the stack specializes, right? Like you're talking about Uniswap. Uniswap at this point has become very, very standardized, right? Of course, people, all kinds of people support it, but another popular DEX comes out of nowhere, right? We will have within a month a bunch of developers who have built with our stack and made public indexers for this X swap, right? That's now the next big thing. Whereas you'll have to wait for centralized providers to write it themselves, do the QA, post the data set on their website. Oh, and then they've chosen the data points that are exposed to you. Maybe there was other stuff you wanted to see that's not there, but you don't have control over that experience. So that's where we specialize here is when you want to rebuild DeFi platforms. You want to, let's say, even in the case for a wallet. Wallet is great. You want to expose on your front end one field. You pass a wallet's name. It outputs how many tokens this guy has, the total wallet balance, things of that nature. That's great. You can have an API to do that. But now, what if that wallet is moving to the future? That's like what you see now. But as our ecosystem is expanding and scaling, the quality of these applications are become much better. Now they want to create a dashboard in their wallet. They want to do all kinds of analytics. Those APIs are now useless. What they need now is a stream of data or an API that they custom build that's real time to populate their dashboards. So you're thinking of a very specific use case of exposing one field to your front end. So yeah, but like I said, in the future. Future's bright. Any other questions? And I hope I answered.
Yeah, perfectly. Just curious about the.
Yeah, it's a very, very valid point. Good? All right, guys. I appreciate it.
We have a speaker Elizabeth Noel. Who's speaking
From Phoenix?
Phoenix?
Yeah, is Phoenix here? No? Okay, we'll take a quick 5-minute. Oh, it's you?
No.
Oh, we'll take a 5-minute break and then we'll come back in. Okay?
Yeah, let me go. Phoenix. Okay. 5-minute break and then. What's going on right now?
I just need to
Okay. Well, it's whatever plugs into that laptop up there, so they can bring their laptop, and that'll be.
Oh, okay. And then that's.
Yeah, and that goes right to the stream.
Okay, got it.
Yeah.
I had a quick question.
Yeah.
So we're planning on using the graph with IPFS in
Okay.
our hackathon project. Are there
Okay.
good examples of are there any examples online of people doing that?
IPFS?
Yeah.
Indexing? Yes. So there's a few different ones. There's a few different repos that work. Let me go ahead and find that for you. In fact, can I get your Telegram? I'll just send you the IPFS examples. Here's my Telegram right here.
Oh, that's super.
Perfect.
Cool. Yeah. That's why we tried to abstract away a bit of the need to do that. Yeah. And I mean, you're highlighting a good point because it's a high barrier to difficulty. There's less people who compete for the prize.
We're good, yeah. Yeah.